So another evidence that our Milky Way has merged with other galaxies is we see these tidal streams of star formation around where the Milky Way is. In this illustration there you can see it looks as though several different galaxies have merged with ours. And whenever you start shaking up gas and dust, you get star formation and it leaves a trail of stars. Another evidence is Omega Centauri, which is one of our very largest globular clusters. You can see it with the naked eye in about May. It'll be just off the horizon and will only be up for a few hours and go back down. So you can watch for that when May comes around. But the interesting thing about Omega Centauri is that the stars within it are all different chemistries. Let me read this. It resides outside of our galaxy. Oh, this is. I'm sorry. Let's go back. I'm going to go back. So Omega Centauri has a bunch of different chemistries within that globular cluster, and if it was made out of the same gas cloud, that wouldn't be the case. So we think that was actually the nucleus of another galaxy that merged with ours, and it's the central bulge that survived. Okay, so now we'll go into this one. This is Messier 54. Resides outside of our galaxies and thought to be the nucleus of the Sagittarius dwarf galaxy. It's being pulled in by the Milky Way's gravity. That's kind of cool. The Milky Way is warped, similarly to the galaxy ESO. So this is an actual picture of our galaxy, but I'm going to see if I can move that. There you go. But it's a picture of another galaxy that looks like ours. We know that ours is warped like that, and we think it's because of the large and small Magellanic Clouds that are other galaxies that are very close to ours and orbiting ours. So here's an illustration of distances of these other galaxies that are kind of close to us. Here's our Milky Way. So here's the small Magellanic Cloud, there's the large Magellanic Cloud, and they seem to be orbiting around our Milky Way. The Sagittarius dwarf galaxy is more attached, that's not in this illustration. But if we live south of the equator, we were in Australia or Chile looking up at the sky, look at that. We would be able to see the large and small Magellanic Clouds, those two galaxies that are so close to ours just with the naked eye, just like that. Very, very cool. A lot of star formation going on within those galaxies. Oh, there's this picture I was looking for of Omega Centauri. That's the nucleus of another galaxy that we think merged with ours. This is a Hubble Deep Field image, and it shows the galaxies from a long time ago. So it took pictures. Well, it says here the image required 800 exposures taken over the course of 400 Hubble orbits around the Earth. The total amount of exposure time was 11 days, 11.3 days, taken between September 24th, 2003 and January 16th, 2004. So in other words, they had to leave the camera on for a long period of time to get enough light from those galaxies that are so far away to actually even see them. But when we looked at them, and we know that these are really old, that they are galaxies that formed close to after the Big Bang. Some of them are just billions and billions and billions of years old. When we look at them closer up, they're kind of weird looking. We don't see a lot of them that look like our galaxies do today. So these are evidences that we think show that galaxies don't form by a monolithic collapse. They don't have one giant molecular cloud that collapses into globular clusters and a disk and a bulge. but that they started as these small galaxies, small clusters, and that they are attracted to each other by gravity, and they start to merge. And as they merge, they make a bigger galaxy. Then they merge with another one and make a bigger galaxy until they have what we see today. So in these deep field pictures, we also see mergers. We see collisions. You can see where there's streaks around things, where another one is being pulled into another galaxy. And so we know these mergers are real, and we can actually see them in space. Any given night, we can see somewhere in space galaxies that are forming together. Now, this takes millions and millions of years for them to come together, so we won't see them in our lifetime go from two separate ones to one big one. But we can see the stages. There we can see again where here's one that's starting to come together, here's one that's getting closer, here's another one that's getting closer yet, here's one that's already merged and leaving trails. So we can see the pattern even though we can't watch it actually happen, except in computer simulations, which are very cool and we can see. So while the universe expands and everything moves away from us, the galaxies in the local group actually move towards us. So we talked about the universe expanding. But when gravity is stronger than the force that's making things expand, gravity then wins. So here's our local group of galaxies. This is what's closest to us. There are at least 45 galaxies in the local group, the largest being Andromeda, the Milky Way, and the Triangulum galaxies. So looking in there, look in this picture there, you can see in red the Milky Way galaxy. You can see down in the lower, the next big blob is Andromeda galaxy. And then down, kind of between them both and down a little, is the Triangulum galaxy. So those three are the big ones. And they are all spiral galaxies, those three. But we have a lot of dwarf galaxies that are around us. So you can see the large and small Magellanic Clouds, the Sagittarius dwarf, all kinds of dwarf galaxies. They are all going towards the center of mass. So they're all pulling towards the middle. And eventually, they will all merge with each other. We are headed towards Andromeda right now. In 2.5 billion years, we will merge with Andromeda, and we will probably lose our spiral shape, and they will probably lose its spiral shape, and we will end up with a large ball elliptical galaxy. And we'll be looking at different types of galaxies in our next lecture. And that's a sneak preview of the kinds of galaxies that we'll be talking about later on. So this is kind of an experiment to see if this type of lecture works. I welcome your comments. You can email me and tell me if this is working for you or not, or if you'd rather just read, or just what's better for you. So, happy studying, and I'll talk to you on the next lectures.